of handling exceptions, but I thought first we'd take a look at how to throw them. So I'm going to create a new class here. Let's create a new class, and I don't really know what to call it, so I'll just call it test or something like that. And I'll give test a method. I don't want a main method, but I'll give it some kind of method. Let's say public void, I don't know, run or something like that. This is just stuff that I'm making up off the top of my head. And let's assume that we want to call run in the main program here. So we could say, let's say test equals new test, and then we want to call run, so we say test.run. And in test.run, let's just put a sys out so that it does something. I'll just say running successfully, and let's just run this and check that it works, which is always a good idea. There we go. Now let's suppose that run actually has to do something that could go wrong. So I don't know what, but let's imagine that it could go wrong somehow. So let's say int value equals 0, and let's imagine that this is some kind of, in fact let's not call it value, let's call it code, and let's imagine that this is some kind of return value from some complex process. And we'll imagine that 0 means success, so 0 equals success, and anything else, like anything else is like 1, 2, 3 is going to mean failure. So let's say anything else equals error code. Now you throw an exception when something goes wrong in your code. So I mean there are kind of slightly different schools of thought on when you should throw an exception, because back in the days when I was learning C++, I always read that you should only throw an exception if something goes wrong that shouldn't happen. And in Java the same philosophy is kind of followed, but not really so rigorously, because for example if you have some code that looks for a file and then you throw a file not found exception, and imagine that that happens whenever the file happens to not be there, but it's just some random file which could be there or could not be there, then throwing and catching a file not found exception becomes part of the normal operation of the program. And arguably that's bad coding, but different people seem to have a different opinion on that. But the bottom line is, an exception is for when something goes wrong, and some people say that this should be something which is not expected to happen during the normal running of the program, but people do differ about that. So we'll assume that something's gone wrong, and we'll say that if code is not equal to 0, then this means something's gone wrong. So something's wrong, and we're going to throw an exception. And the way we do that is, firstly, in the method header here, we have to say what kind of exception the method might throw. And so you need to pick kind of a suitable type of exception. And if you go to Google and you search for Java, possibly your version of Java, let's say 7, and exception, and then go to the API doc for the class exception, you can see a massive range of subclasses here which you could throw. And some particularly common ones are, for example, file not found exception and IO exception. So you could pick an existing exception to throw from one of these. And you could also throw exception itself. You could just throw exception, although that's considered kind of bad practice. And let's imagine that you've looked at all these different exceptions and you decided that IO exception is the one you want. IO exception. IO exception means input output exception. So you could throw this if something goes wrong with the input or output of the program. So let's say here throws IO exception, and so that's throws with a lowercase t, because this is a keyword and the keywords have lowercase letters, and IO exception uppercase I, because this is an actual class. Exceptions are classes. And now here, where the thing actually goes wrong in your code, if it goes wrong, you can say throw new IO exception. And exception classes, they all allow you to specify a message here. So we could say here something went wrong. Actually, that's a terrible error message. How about could not connect to server, something like that. And now you'll see that now that I've saved that, I've got an error in main. And notice I'm not throwing that exception at the moment because the code is equal to 0, so this won't run. All that will happen is it says running successfully. But the point is that this could be a return code, and here we're checking has something gone wrong, and if it has, only then will we throw an exception. And if we throw an exception, it will leave this method at that point and bolt straight out of it. And we're now forced to handle this here. So I'll use the stuff we saw in the last tutorial. I'll click the error message and surround with try catch. And here we could say e.print stat trace, or we could present some kind of error message to the user, or I could do something like sysout e.get message, and get message will return that message that I supplied to the constructor right here. So if I save that, the error goes away, and if I run it, well, it says running successfully. But if I now change this to be 1, let's say, and now I run it, it's going to say could not connect to server. There's just one more thing that I want to show you in this tutorial, although there's going to be a bit more to say about exceptions, which is, what if you don't find an exception that you like the look of, you don't find an appropriate one? You can create one of your own. So I might create a package here called exceptions actually, but for the moment let's just bung it in this default package. So I'll right click and I'll go to new class, and let's call this server exception. I don't think there's already a server exception, and I don't want a main method, and I want this to extend exception. So I'll type here for the superclass exception, I'll click browse, and I'll browse to java.line exception and click finish. So we've got a class server exception which extends exception, and I'll also give it a constructor. So I'll right click and go to source and generate constructors from superclass, and I'll just use the constructor. I'll say deselect all, and then I'll select just the one that takes a string as its sole parameter. And you can also supply other exceptions that are the root cause of this exception, but we'll just stick with a message for the moment. So I click OK, and I'll just let that go to super, invoke the superclass constructor here. So this doesn't actually do anything new, and you could make it do new stuff if you want. You could give it new fields, new methods that allow you to provide new information about the nature of the exception, but for the moment I'll just leave it as it is, and I'll change this IO exception to server exception. In fact, what I'll do is I'll just comment this out, and let's just paste this down here, and I'll change this now to server exception, and I click save, and let's look at the error. And I will change this here to server exception as well, so it throws a server exception. And here I'll also change this to catch server exception. And we could have made server exception a subclass of IO exception. If we think that server exception is a type of IO exception, then we could have made it extend IO exception. But here I'll just create a brand new exception with the exception class as its parent, and we'll save that. and I'll just run that, and it's the same result as before. If the exception's thrown, it catches my server exception, and in this case it's printing the message. And we could also say something like e.print stack trace if we want, and then if I run that, we'll also get this kind of error message, and we can find out where the exception occurred. And I can even click a bit further up the stack trace here and find out precisely where it originated from. And notice that if we throw the exception, we don't run this line, because as soon as you say throw new exception, it leaves the method that you're in. So that's it for this tutorial, and we'll look at exceptions a bit more shortly. But until next time, happy coding.